Hello, everybody, and welcome to this week's lesson on ratios, proportions, and percents. For this lesson, you will need your welcome packet, pencil and paper, and you're definitely going to want a calculator with you today because we're going to be working with some big numbers, and you're not going to want to do all these calculations by hand. So we're going to start off with this warm-up question that you see on the screen. It says, in a class, there are 15 people from Kentucky, and the rest of the people are from out of state. There are 35 people in the class total. What is the ratio of Kentuckians to out-of-staters? So if you've been keeping up with your homework, then this problem should look familiar to you. This is a problem that's asking us to write a ratio. Do you remember what a ratio is? So a ratio is a comparison of two numbers. We are being asked to compare the number of Kentuckians to the number of out-of-staters in this class. So we need to compare Kentuckians. I'm going to abbreviate that with KY. Kentuckians to out-of-staters. OOS. Kentuckians to out-of-staters. So how many Kentuckians are there in this class? Well, there are 15 people from Kentucky. There are 15 people from Kentucky. And how many out-of-staters are there? Well, it says the rest of the people are from out of state, and there are 35 people in the class total. So we're going to need to figure out how many out-of-staters there are. We're going to take that class total, 35 people overall. We'll take away the Kentuckians, and that should give us the number of people from out of state. So we will be left with this ratio of 15 Kentuckians to 20 out-of-staters. Now with ratios, what do we usually do at the end? So oftentimes with ratios, our last step is to reduce or simplify the ratio, just like we do with fractions. So we want to look at our two numbers here, and we want to find the greatest common factor of 15 and 20. So what is the greatest common factor of 15 and 20? It's 5. Right? 5 is the largest number that will go evenly into 15 and also 20. So we're going to divide the top and the bottom by 5. And we will be left with 3 to 4. So the ratio of Kentuckians to out-of-staters is 3 to 4. For every 3 Kentuckians in the class, there are 4 out-of-staters. All right, so what are our learning goals for this week? By the end of the week, you will be able to compute unit rates, use scale factors to determine the magnitude of a size change. And that means basically converting between things in real life and things in scale drawings. You'll solve real world problems using ratios and proportions, and you'll solve real world problems using percentages. So we've got a lot to cover this week. We have already gotten some practice with computing unit rates, so that should be a review for you. And this week's lesson is in collaboration with Miss Alex's class, where she is focusing on talking about elections and voting in the Electoral College here in the United States, doing a little unit on elections and voting and government here in the US. And so the math that we're going to be doing this week is also going to be focusing on information surrounding votings, elections, and the Electoral College in the United States. So that is the main reason why you're definitely going to want to have a calculator out next to you, because we're going to be working with real data, real information about voters in the United States, and some of these numbers are pretty big. So a calculator will just make the calculations a lot faster for you. Okay, so let's do a little review here of ratios and unit rates. So we said in our warm-up problem that a ratio is a comparison of two numbers. What is a unit rate? What is a unit rate? Well, if you think back to our lesson where we first talked about unit rates, you'll remember that a unit rate is a special type of ratio. It's a special type of comparison. It is a comparison to one. So whenever you are comparing some amount to the number 1, you are talking about a unit rate. For example, 75 miles per hour, right? If you're talking about driving your car, 75 miles per hour, that's 75 miles per 1 hour, right? So that's an example of a unit rate. Okay, so as we do a little extra practice with ratios and unit rates, we are going to be working with this data that I have up on the screen here. So we have a table, and our table has a title. It says Fayette County 2020 primary election voter turnout. So this information is from the Kentucky State Board of Elections. I pulled this off of their website. This is real information about voters here in Fayette County. And this is from the 2020 primary election that happened in June of this year. So if you voted in that election in Fayette County, then you are included in these numbers here. All right, so when we look at the table, let's take some time here to check it out. We already noticed the title. It looks like the information is broken up into age groups. So we have 5 different categories for age. And it shows us the ages that fall into each category. So maybe take a second to think about which of these 5 groups you fall into. And then for each age group, we know the number of registered voters, so the people who have signed up to vote in Fayette County. And we have the number voting, so the number of people who actually went out and voted during the primary election, right? So the total number of people who could have voted, right? The total registered voters, and then the number who actually voted, the number voting. All right, so let's look at number 1 here. What was the ratio of registered voters in age group 1 to total registered voters? Okay, so this is a similar type of problem to the one we just did, where we're being asked to write a ratio. Remember, a ratio is just a comparison of 2 numbers. So we're being asked to compare registered voters in age group 1 to total registered voters. So how many registered voters do we have in age group 1? Well, we have 23,491 registered voters in age group 1. 23,491. And how many total registered voters do we have? How many total? Do we know? No, this doesn't actually tell us the overall total of all of the registered voters together. It tells us the total for each group, but it doesn't tell us the overall total of registered voters. So what do we need to do to figure out the total number of registered voters? We need to add, right? So this is an opportunity to take out your calculator. You're going to go ahead and you're going to add up all of these numbers. I'm going to do that here with you. My actual calculator broke recently, so I am on my phone calculator, as many of you might also be on your phone calculator right now. So 23,491 plus 50,306 plus 59,483 plus 41,035 plus 53,652. So I get a total, when I do that, I get a total of 227,967. So we get this ratio of these 2 large numbers. We get this ratio of 23,491 to 227,967. So that is our ratio comparing registered voters in age group 1 to total registered voters. Now, like we said in the last problem, usually with ratios, we reduce our answer as much as possible. We're gonna not worry about that. Right now, with these numbers, they're very large, and it would take us quite a while to figure out if we can reduce them or not. We're not gonna go through that. However, if you would like to know if you can reduce them or not, see if you can figure it out, and send me a message if you have questions about how you would figure out how to reduce them. Okay, so that is our ratio, number 1. Let's look at number 2. How many age group 4 voters were there per age group 1 voter? That should say per age group 1 voter. So what type of a question is this? This is a unit rate question. We're being asked to calculate a unit rate, and the main way we know that is we see it says per age group 1 voter. So we're talking about the number of people in this one group per 1 voter, right? So comparing the number of people, the number of voters in age group 4 per age group 1 voter. Now, these are actual voters we're talking about. We're not talking about registered voters anymore. We're talking about those people who actually went out and voted, the people in the voter turnout, right? People who turned out to actually vote. So, how do we calculate a unit rate? We divide. Again, this is something we talked about in Unit 2, where we first started talking about ratios and rates and fractions. So we want to know age group 4, I'll call that AG4, compared to age group 1. So age group 4, how many voters were there? There were 17,340. And how many voters in age group 1? There were 7,186. So to figure out the number in age group 4 per voter in age group 1, we're going to divide. So 17,340 divided by 7,186. And I get 2.41 something, 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 right? So a long decimal number, 2.41. And I'm going to round this number, I'm going to round it to the nearest 10th. So round it to the nearest 10th, that will become 2.4. So that means there were a little over 2 on average 50 to 61-year-olds who voted for every 1 17 to 24-year-olds who voted, right? So more than 2 in that older age group for each 1 in the younger age group. All right, so our next big topic here is proportions. Proportions take what we know already about ratios and build on top of that. So I want you to take a minute to think about that word proportion and think about if you've ever heard or used any words that sound kind of similar to it. So maybe words like proportional or disproportionate or out of proportion, or any others you can think of that are similar. So all of those words, or even portion, if you're thinking of a portion is talking about a part of a whole, all of those words are talking about the relationships between things, relationships between sizes of things, relationships between how things look. And that's what proportions are all about. Proportions are all about relationships between numbers. So the mathematical definition of a proportion, the definition we're going to use, is that a proportion is two ratios that are equal. So remember, a ratio is a comparison. So a proportion says this comparison over here means the same as this comparison over here. That's what a proportion is, two ratios that are equal. And so if you already know a little bit about equivalent fractions, this is actually basically the same thing, except we are not only talking about comparisons of a part to a whole, we're talking about any kind of a comparison here. So I have an example here. It says, Aron is testing a new cookie recipe before a party. The recipe calls for 1 cup of flour and 2 eggs. Aron bakes the cookies and they turn out well, so he decides to double the recipe for the party. He uses 2 cups of flour and 4 eggs. So what Aron has done is he has created a proportion. We have this situation where we're comparing cups of flour to number of eggs. And we have this first comparison of 1 cup of flour for 2 eggs. And then in the second round, when he goes to make the recipe again, right, he uses 2 cups of flour and 4 eggs. So he increased both of those ingredients by a factor of 2. He doubled both of the ingredients. And what he did was he formed a proportion. So in this example, it might be a little bit more familiar to you. It might kind of jump out at you that Aron did this proportion correctly, right? That he correctly doubled his recipe. But let's say you have a situation where the numbers are a little bit harder to think about, or you're not exactly sure if 2 ratios do form a proportion. One way that you can check is you can check a characteristic that all proportions have. So with all proportions, so for all proportions, the cross products are equal. And I've lost my little pen here. Here it is. So for all proportions, the cross products are equal. So if the cross products are equal, it's a proportion. If they're not equal, then it's not a proportion. The cross products are always equal in a proportion. This is one way that you can check and see if something is a proportion. So let's double check that here with Aron's flour and eggs. So we'll check one cross product. So 1 times 4. Right, cross product means multiplying along the diagonals. So 1 times 4, that equals 4. And 2 times 2, that also equals 4. Another way I could write this out is I could say, well, 1 times 4 is equal to 2 times 2. Right, 1 times 4 is equal to 2 times 2. Those two cross products, they give you the same result. Right, we would end up with 4 equals 4. So that is one type of proportion problem that we might see on the GED test. The type where we are asked to check and see if a situation really is proportional or not. So let's see a related example here, and we'll give it another try. We're going to check again to see if we really have a proportion using that characteristic that the cross products have to be equal. So Aron is testing a new cookie recipe before a party. Recipe calls for 1 cup of flour, 2 eggs. They turn out well. He makes the recipe again. He decides to double it. He uses 2 cups of flour and 5 eggs. Did he double the recipe correctly? Another way we could say that is this situation proportional do these two ratios form a proportion? So let's check. We are still comparing flour and eggs. Pen keeps disappearing. There it is. We're still comparing flour and eggs. So the recipe is the same. It says, start with 2. It says 1 cup of flour for every 2 eggs. And then the second time around, Aaron did 2 cups of flour and 5 eggs. So let's check these cross products, because what we're looking for here is we're looking to see if these two ratios really are equivalent to each other. Do they really mean the same thing? That's why I have a little question mark there over the equal sign, because we're checking it out to see if they really are equal. So let's see, 1 times 5, is that equal? Is that equal to 2 times 2? Well, we get 5 is equal to 4, and that is definitely not true, right? 5 is actually not equal to 4. Put a little slash mark through that equal sign. That means not equal to. 5 is not equal to 4. So this is not these two ratios do not form a proportion. 1 to 2 is not equal to 2 to 5. So did he double the recipe correctly? We would say no, he did not. So that's one type of proportion problem we might encounter, where we need to check and see if a situation is a proportion. How do you know if you're looking at that type of problem? Well, the problem will involve a comparison of 2 things. So in this case, comparing cups of flour and eggs. And then you will be provided with 4 numbers, right? Because to set up a proportion, you need 2 ratios. So altogether, you need 4 numbers. So it'll be this type of question if you have a comparison of 2 things and you are given 4 numbers to work with, and you're asked to check and see if you really have a proportion. The next type of proportion problem we might encounter is where we are using proportions to solve for missing information. And this type of proportion problem is much more common on the GED test because it's what proportions are most useful for. So we're going to see how we solve for missing information here. And we're going to use the same data that we saw before. We're going to be using this information about voter turnout in the 2020 primary elections. So we have the same table here. Let's take a look at the question. It says age group 5 had 53,652 registered voters and 29,028 actual voters in the 2020 primary elections. If age group 5 and age group 2 were proportional, how many actual voters would have been expected for age group 2? So we know how many registered voters there are. We are saying if those 2 age groups were proportional, how many actual voters would we have expected if these people who are between 25 and 34 years old came out to vote at the same rate as people who are 62 and over? So even just by quickly glancing at these numbers, we might be able to make an estimate. So I see, looking at them, that the actual number of registered voters is pretty close, right? Age group 2 is 50,306. Age group 5 is 53,652. So if those 2 groups were proportional in their voter turnout, then we would expect age group 2 to have a similar number of voters, similar to 29,028. So probably just a little bit lower because their number of registered voters is a little bit lower. And we know that's not actually the case, right? We just, before I scribbled it out, we know it's like 13,000 something, right? So we know it's actually much lower voter turnout. But let's do the calculation now that we have an estimation. So let's set this problem up. How do we know that this is a problem where we can use a proportion to solve it? Well, this problem starts off by giving us a ratio where we're comparing two things. We're comparing registered voters and actual voters. So we're comparing two things. And we have three numbers that we can work with, and we are trying to figure out the fourth number, right? So we've got these three numbers that we can work with, and we're trying to figure out the fourth missing number. So that's how I know that this is a proportion type problem. First of all, the question says the word proportion in it, right? So that's one clue. Another way we know it is that we're comparing two things. We have three numbers to work with, and we are supposed to look for a fourth number. So the first step here will be to set up the proportion. Now, I think this is the hardest part, because when we get to actually solving for the missing number, it's just some calculations we have to do. But setting up your proportion correctly is the most important part. It's the part you need to pay the most attention to. So first thing we want to do, like we did in the last one, is we want to think about what are we comparing in this problem? Well, we're comparing registered voters and actual voters. So I'm going to go ahead and I'm going to start setting up my proportion. My proportion is going to be two ratios that are equal. And I'm going to fill in my first ratio, the complete one. So age group 5 had 53,652 registered voters, 29,028 actual voters. I'm going to put the smaller number on top, even though it actually does not matter which number goes where, as long as you are consistent for both of your ratios. So if I decide to put actual voters on top here, then actual voters are going to need to go on top on the other side. Okay, so age group 5, this is the ratio for age group 5. Now I'm going to come over here to my second ratio for age group 2. I know how many registered voters there were. There's 50,306. And I want to know how many actual voters would we expect if this was a proportion, if this is a proportion. So this is my missing value here. I'm going to put a V here for number of voters. So the V is just a placeholder for that missing number. V for voters. Okay, so right, step 1, you set up your proportion. How do you do that? First thing you do is you think about what are the two things I'm comparing. Here I'm comparing registered voters and actual voters. You use that to guide you in setting up your two ratios. So here, right, I've got actual voters on top, registered voters on the bottom. Doesn't matter which one's top or bottom, as long as both sides of your ratio, both sides of your proportion match. So you don't want the two ratios to be like flipped around from each other. Okay, so we have completed step 1. Now on to step 2, we're going to actually solve for that missing number. Now to solve the proportion, to solve for that missing number, we're going to take advantage of that characteristic that all proportions have, that the cross products have to be equal. So to solve this proportion, first thing we're going to do is we're going to cross multiply. Right, that's what we did in the last problem when we were trying to just check that it was a proportion. Same thing here, we're gonna cross multiply. So we are saying, we're gonna say that 29,028 times 50,306 is gonna need to be equal to 53,652 times whatever V is. I'm gonna write out that multiplication. I really should have given myself more room on this slide. Oh well. So I hope you have your pencil and paper with you and you've given yourself plenty of space to write this out. So we're saying that 29,028 times 50,306 is going to be equal to 53,652 times V. So cross multiply, and now 53,652 times V, I can't do that multiplication because I don't know what V is yet. But on the other side of the equal sign, the left side, I can actually do that multiplication. So I'm gonna do that. I'm gonna do 29,028 times, help if I clear my calculator first, 29,028 times 50,306. I get this really big number. In fact, my calculator is giving it to me in scientific notation. It's so big. We haven't talked about scientific notation yet, but we will get there. So I get this really big number. I get 1 billion, like Dr. Evil, $1 billion, 1,460,283,000 when I multiply those two numbers together. And that is equal to 53,652 times whatever V is. Okay, so we did all of our multiplying here. Cross multiplied. Now, right, it is our goal to figure out what that missing number is. We're using this characteristic of proportions that the cross products have to be equal. We cross multiplied, but now we need to figure out what V is. V is still kind of chilling over there with the 53,000. That's not helpful. We need to know what is V equal to. So our final step here, which I'm gonna have to squeeze in at the bottom here, is gonna be to divide. So if you know that, for example, let's do it with some smaller numbers here. If you know that 8 is equal to 4 times some number V, well, you probably know that that number V has to be 2. But another way you could figure it out would be by dividing. You could say, well, V must be equal to 8 divided by 4. So that's what we're doing here. We're going to divide so we can figure out that missing number. So we're going to take 1,460,283,000. We're going to divide it by 53 23,652. And that will tell us what V is. So I'm going to go ahead, I'm going to do that calculation. I'm going to divide by 53,652, and I get 27,217.6. So I'm going to round that to the nearest whole person. So we don't really want parts of people here, right? We want the whole person. 27,218. I'm going to round that to. So that is our missing number V. So if these two age groups were proportional in their voter turnout, we would have expected these 25 to 34-year-olds, we would have expected to see 27,218 of them vote if those two age groups were voting at the same rate. However, that's not what happened, right? The younger folks, the 25 to 34-year-olds, did not vote as much. Only 13,732 of them voted. So, to use a proportion to solve for missing information, first thing you do, you set up your proportion. How do you set up your proportion? You think about the two things that are being compared, and then you use that as a guide to set up your two equal ratios where one of them has a missing number. Once you have your proportion set up, the second stage is to solve for the missing number. To solve, you cross multiply and then divide. So notice here, right, I have a lot of stuff written out here. However, essentially what we did was we cross multiplied where we could. So we did 29,028 times 50,306. We cross multiplied, and then we took that answer and we divided it by 53,652. We divided it by the number we hadn't used yet. So that is essentially the calculation, right? Cross multiply on the diagonal that has two numbers, and then divide by the number you haven't used yet. All right, so let's get a little bit more practice with this. Because based on the 2010 census, Kentucky has a population of 4,350,606 and has 8 electors in the Electoral College. If population and number of electors is proportional for all states, how many electors should each of the states below have based on their population? Now, for those of you in Miss Alex's class, you will be talking about the Electoral College this week. Now, I know not all of you are working with Miss Alex, so I'm also going to post the video that she posted about the Electoral College, where it talks about what the Electoral College is, why it's important, how it's used. But basically, what the Electoral College is it is a group of 570 people, I believe. Different numbers of electors from each state who cast votes in the presidential election based on how people vote in their state. So when you cast your vote for who's going to become president, you're kind of one step removed from the actual electing of the president, right? You cast your vote, and then the electors in the Electoral College in your state, they cast a vote based on how people in their district voted. So that's why the election can get a little bit more complicated beyond just who got the most votes, right? It really comes down to those Electoral College votes. And the number of electors that each state has is somewhat related to population. but it is also related to other things. Many other factors go into determining the number of electors that each state has, and there are various pros and cons to having an electoral college. So the Electoral College is super important, and I highly recommend watching that video about what it is and why it is the way it is if you are at all interested in the US and how things work in the US, how the government works, how the election process works. So here, we are talking about the Electoral College. Kentucky has a population of this much based on the 2010 census. We'll have an updated number soon because we are currently in the middle of a new census, right? We're currently in the middle of the 2020 census. So if you haven't filled out your census yet, you should definitely fill it out. It's very important. It determines the number of electors that we get in Kentucky, but more importantly, it also determines the amount of federal funding that we get for various things that we all make use of. So Kentucky has a population of 4,350,606, and it has 8 electors in the Electoral College. If population and number of electors is proportional for all states, so if all states have the same relationship between population and electors as Kentucky, how many electors should each of the states below have based on their population? So we have this table, and now these are real numbers that I pulled. These numbers come from the 2010 census data. We have 3 states here, and we see their population. And we are going to figure out the number of electors that each of these states would have if they were similar to Kentucky. So in this problem, I'm gonna first set up my proportion. I'm going to start with the first state. I'm going to start with Florida. So set up my proportion. I am comparing electors and population. So my first ratio will be that ratio about Kentucky. I'll be doing 8 electors in Kentucky, and Kentucky has a population of 4,350,606. And then my second ratio, right, I'm going to start with Florida here. So Florida, we're trying to figure out how many electors based on Kentucky. So I'm going to call this missing number of electors E for electors. And Florida has a population of 18 million, so quite a bit bigger than Kentucky, 18,900,773. Okay, so I have my proportion all set up. Now I just have to go ahead and do my calculations. So first thing I'm going to do is I'm going to cross multiply 8 times 18,900,773. And I get an answer when I multiply those numbers. So right, first thing I'm doing is I'm cross multiplying. Eight times 18,900,000 blah, blah, blah. Then we get this answer of 151,206,184. That's the result of my cross multiplying. And now I'm going to divide by the number I haven't used yet. Right? I'm going to divide by the 4,350,606. So divided by 4,350,606. And I get an answer of 34.7 electors. So since we can't have 0.7 electors, I'm going to round that to the nearest whole person. I'm going to round that to 35 people, 35 electors. So Florida should have 35 electors if they were proportional to Kentucky. Now, what's the actual number of electors they have? They actually have 29 electors. So they have a little bit, they have fewer electors based on their population compared to Kentucky. Okay, so what I challenge you to do is I challenge you to pause the video and I challenge you to calculate the number of electors based on Kentucky for New York and the number of electors based on Kentucky for Ohio. What I'm going to do, I'm going to fill in those numbers right now. And then you're going to see if you got the same number. So I'm not going to say how I'm setting it up. I'm going to challenge you to set it up. I want you to pause the video and see if you can figure it out. Okay, so there are our number of electors based on Kentucky for New York and Ohio. You can see for each of those I rounded to the nearest whole person, the nearest whole elector. So if you did not get the same answers as me, I would go back and double check. Let me know if you do have any questions. But what are some things we can notice here? So again, we notice that New York has fewer electors than we would expect if it was proportional with Kentucky. Same thing with Ohio. Ohio has only 18 electors, whereas we would expect them to have 21 if they were proportional with Kentucky. So that's something I wonder about. I would wonder about why are these numbers lower than it seems like they should be if everyone was kind of proportional, if everyone had the same number of electors based on population. And that's actually something we're going to be discussing on Friday of this week. Okay, so last thing that we are going to tackle in this lesson, we are going to tackle proportions in scale drawings. So this is just another very common type of proportion problem that you might see show up where you are taking something in the real world, like a country or a city or a house, and you are scaling it down onto a drawing or a map, right? So same thing, taking something big and shrinking it down. So here it says the scale on a map says that 2 miles equals 1 inch. But right away I see that this problem is comparing miles and inches. If the length of New Circle Road measures about 10 inches on the map, what is the actual length of New Circle Road? So this is an actual map of Lexington here. This is from Google Maps. So I just took a screenshot and you can see down here, we've got the map scale. It's showing us the distance that 2 miles is on this map. So down at the bottom there is where we see the map scale. So the scale on the map says that 2 miles is 1 inch. If the length of New Circle Road measures about 10 inches on the map, what is the actual length of New Circle Road? So this is a proportion type problem. We're comparing miles and inches. We're given 3 numbers and asked to solve for a 4th. So I'm going to continue setting up my proportion here. So I've got 2 miles to 1 inch for my first ratio. And then for my second ratio, I've got some number of miles. So I'm going to call it N for New Circle Road. for 10 inches. Okay, so our proportion is set up, and now we solve. We're first going to cross multiply. We're going to do 2 times 10, which gives us 20. And now usually we would say we need to divide, right? We would need to divide by 1, but we know dividing by 1 doesn't really change our answer at all. So you could skip that step if you wanted to. And there's our answer. So that means that N, the length of New Circle Road, is 20 miles. So if it's 2 miles for every inch, if we have 10 inches, that means New Circle is 20 miles. Okay, so I had said at the beginning of the lesson that we were going to do percents in this video as well. We're going to take a break here. We're going to save percents for another video because I think this work on proportions is enough to be getting on with for now. I want to give you plenty of time to work on it and feel comfortable with it. So this is a summary of the homework for this week. You have your problem of the day, which went up on Monday, your Tuesday review, which went up today on Tuesday. And your worksheet Wednesday will be up on Wednesday. And then on Friday, we're going to have a little discussion about a graph. So keep an eye out for the what's going on in this graph post that'll go up on Friday. Again, that's just a discussion. We're not going to be like solving a bunch of math problems. We're just going to be looking at a graph, thinking about it, talking about it, thinking about the numbers that it shows us. Make sure you're keeping up with our Google Classroom posts and reading what goes up there each day. If you do have any questions, please let me know. Otherwise, thank you so much for joining me, and I will talk to you all again very soon.